Hello friends, good evening. Yeah, so today we are going to see some new data science interview questions. Okay, so we will start with our first question. Let me write it down. Define confounding variables. This is the first question. Define confounding variable. Okay. Try to answer this question. What is the confounding variable? Sorry, confounding variable. There is a spelling mistake. Okay, yeah. Define a confounding variable. Okay, so confounding variables are also known as the confounders. Okay, confounders. These variables are a type of extraneous variable that influence both dependent and independent variable. See, firstly understood, confounding variable, this is also called as a confounders. Okay, these variables are a type of extraneous variable, that means outside variable, that influence both independent and dependent variable by causing mathematical relationship between those variables that are associated but are not casually related to each other. How it is influencing? How it is influencing? It is adding, sorry, yeah, for both independent and dependent variable, causing a mathematical relationship between those, right, that are associated but are not casually related to each other. This is the confounding variable. And okay, so did you understand what is the confounding variable and how why it is causes, what was the changes it is going to make, what is the, if you have any issue let me know in the chat window, I will explain it again. Okay, confounding variable are also called as the confounder. Okay, this variable are a type of extraneous variable that influence both independent and dependent variable, causing mathematical relationship between those variable that are associated but are not casually related to each other. Is it clear now? Okay. Now, today's next question is, how should you maintain a deploy model? How should you maintain a deploy model? Sorry. Okay, try to answer this question. how should you maintain a deployed model? See, when we are having machine learning model, we are deploying that machine learning model and then submitting to the customer, right? Or for our purposes. So we firstly have to deploy the model, right? Then we can then we can check whether our data, that model is giving accuracy or not. Okay, how should we can do that? Okay, after deployment. So there are 3 to 4 ways we will see one by one. Firstly is like a monitor. Okay, constant monitoring of our model is needed, right? It is need to determine their performance and accuracy, right? Is they are giving the same accuracy or not. When you change something, right? When you change something in your data, input data, for example, you want to figure it out how your changes are going to affect the things, right? This needs to be monitored to ensure it's doing what it's supposed to do, right? Means whenever in future, right now we have some data, right, for test, for example test data, but in the future we will get some another kind of data, right? So we have to monitor, is that data affecting our model? Is it giving the accuracy that we are actually having, or the accuracy goes down, right? This is the first way, right? Then next is the evaluate. Okay, evaluation metrics of the current model are calculated to determine if new algorithm is needed, right? Means firstly we have understood, okay, our model's accuracy goes down, so we have to evaluate, right, that the current model are calculating and determining new algorithm that needed or not. Is this a reason to the accuracy goes down, right? Then the next one is the compare. Okay, once we have find out like this as the new model, it is we need the new model. This model is not working fine for the same data set. Okay, so next step is like we have to compare both the models, right? Our old model and our new model, right? And we have to determine which of the model is performing the best, right, for our data. Now, and the last step is rebuild. The best performance model is rebuilt on a current state of our data, right? So how should you maintain a deploy model? Firstly, monitor the model, check the accuracy of our model. Whenever the changes happen in the input data, we have to check, is there any impact of those changes on our model's accuracy, right? Is that accuracy increasing or going down? Okay, if that accuracy, we have to evaluate that. Okay, after monitoring, we have to evaluate that, is this a model giving us the accuracy is good? If it is not good, okay, is there any need to do another model for that data set, right? If yes, if we want to do another model, if we will do another model, then compare both the model, old one and new one, right, which is giving us the best accuracy, right? Then whatever model is giving us the best accuracy, we have to rebuild that model, right? This is how we maintain our deployed model. Is it clear for you which of the steps to we are having for the deployed model to maintain a deployed model? Okay, just only 4 steps: monitor, evaluate, compare, and then rebuild. Right? These are the 4 steps required to maintain a deployed model. Okay. Now, to this next question. How can a time series data be declared as a stationary? How can time series data we declare as stationary. Okay. How can a time series data be declared as a stationary data? Is that data is stationary or not? Okay. So, if data is stationary or not, we can find out with the help of a mean and a variance, right? So, if the mean and the variance of the data is constant with the time, that means the data is stationary. Okay, if mean and standard deviation, sorry, mean and variance is not constant with the time, that means the data is not stationary. In a simple way, if we have trend or a seasonality in our data, that means our data is not stationary. If we have trend in our data, that means mean of the data is not constant, right? Mean is continuously increase, right? So that time our data is not stationary, right? So to make our data stationary, we have to remove the trend, right? If we have seasonality, then also our data is not stationary because variance is changing with the time. So whenever mean and variance is constant, that time data is stationary. Whenever mean and variance is not constant, our data is not stationary. But to apply time series model, we always want our data to be stationary, right? If our data is not stationary, right, we have to make that data stationary. Okay, we can't apply a model directly on that data. Those are not stationary, right? Okay, so is it clear now? How can a time series data, we can declare it as stationary or not stationary? Can I get a quick response in a chat window? Okay. So for next question, I am expecting answer from you because every time we are following this. Okay. This is the, I think the easiest one. I think everyone have to know this. Difference between normalization and standardization. Alright. Standardization. Okay. Try to answer this question, difference between normalization and standardization. Okay, firstly, both normalization and standardization are the scaling techniques, right? Both are used to make our data scale free, right? So we will go first for the standardization. Standardization is the technique of converting data in a way that it is normally distributed, okay, and has standard deviation of 1 and mean of 0. See, understood is different firstly. The technique standardization is nothing but converting our data in a way that it is normally distributed and has the mean as 0 and standard deviation as 1, right? And on the other hand, normalization is technique to converting all the values of the data is lie between 0 and 1, right? See, here in the standardization, we will convert our data in the form of normally distributed, right? Here the standard deviation is 1 and the mean is 0. But in normalization, we are converting the data, the values of the data in between 0 to 1, right? This is the first difference. Okay, and normalization also called as a min-max scalar, if you want. Now, next big difference is like standardization take care of standard normal distribution, right? Whenever we want to calculate something, area from some standard deviation, we want a normal distribution as standard normal distribution, right? So standardization take care of that. It will convert our normal distribution to as a standard normal distribution, right? There is some formula difference as well for normalization and standardization. Formula for normalization is like x minus x mean divided by x max by x mean, right? For the normalization. And for the standardization, x minus mu by sigma. This is the formula difference. Okay, so did you understand what is the difference between normalization and standardization? Okay. Now the next question is, what is prior probability and likelihood? Okay, take some time and try to give the answer. What is the prior probability and likelihood? Okay, so firstly, prior probability, it is the proportion of dependent variable in the data set. Prior probability is just only the probability of, or uh, or just only the proportion of the dependent variables in the data set, right? While likelihood is the probability of classifying a given observand, right, in a presence of some other variable. This is the probability of classifying the observation, right, in the presence of some other variables. Did you understood what is the prior probability and what is the likelihood? Prior probability just only the dependent variable of the data, right? Proportion of the dependent variable. Okay, what is the proportion of dependent variable we are having? That is the prior probability. Likelihood, it is the probability of classifying a given observation of a given observand in a presence of some other variable, right? Understood what is the prior probability and likelihood? Okay, now this answer I am totally expecting from you, friends. List out the libraries in Python used for data analysis and scientific computations. Library used in Python for data analysis and scientific computation. Okay. Tell the name of those libraries. Which of the library we are using for data analysis? Okay. So there are the libraries using in a there are the libraries present in a Python that we are using for the data analysis. Name of those libraries like SciPy, Pandas, Matplotlib, NumPy, Scikit, Seaborn. These are the libraries we are using for data analysis. If anyone asks you which of the libraries you are using for data analysis or a scientific computation, so these are the libraries: SciPy, Pandas, Matplotlib, NumPy, Scikit, Seaborn. See, we are every day dealing with these libraries, right? We have to work this library. We have to work every day on those libraries. This library. So yeah, you have to tell the name of this library, right? If they ask you to explain, then only you can explain those. Okay. Now, next question is, what is a confusion matrix? In an easy way, can anyone tell me what is a confusion? Sorry. Yeah, confusion matrix. Okay. What is the confusion matrix, friends? Take some time and try to give the answer. What is the confusion matrix? Okay. So the confusion matrix is the table that is used to estimate the performance of a model, right? Confusion matrix is just a table, right? It is used to estimate the performance of our model. It is the table of the actual value and the predicted values in a 2 by 2 matrix, right? It tabulates the actual values and predicted values in a 2 by 2 matrix, right? So as we know, in confusion matrix we have actual values and predicted values. So there we have something we called as a true positive, false negative, true negative, false positive, this kind of value. What was those? Okay, so true positive, it denotes like of all those record where the actual values are true and is predicted as a true, right? True positive means all the records are true and we have predicted it as a true, right? Out of all the positive records, how many we have predicted is as a true, right? Now the next is a false negative. What is the false negative? It is the all those records where the actual values are true, but we predicted it as a false, right? Means actually that value is true, but we misclassified that. The ratio of those is called as a false negative. That is the false negative. Okay. Then what is the true negative? Here the actual values are false and we predicted it as a false, right? Means wherever the actual values are false, we will predict it as a false. Means wherever the actual values are negative, we will predict it as a negative. That means the true negative. Okay. And then what is the false positive? What is the false positive? The actual value are false, but we predicted it as a true, right? So this some sort of value we are getting from a confusion matrix to calculate the accuracy of our model, right? This is the confusion matrix. It's just a table form. In that table, we are having true positive, false negative, true negative, false positive value. With the help of this, we can calculate our model's accuracy, right? Now, can anyone tell me what is a bias in a data science? What is bias? What is bias? What is bias? Okay. So bias is a type of error that occur in the model because of using algorithm that is not strong enough, right, to capture underlying patterns of the data or the trains, right? In other words, we can say that this is the error occur when the data is too complicated for the algorithm to understand, right? So it's end up building a model that makes the simple assumption, right? The bias is lead to lower accuracy because of the underfitting, right? So the algorithm that can lead high bias are linear regression and logistic regression. Getting it? Bias is nothing but whenever our model are not able to identify what is the pattern inside a data or what is the strain existing inside a data, right? It will lead underfit, right? That means the accuracy of our model, strain and test both are less. That means our model is not good. It is not giving us the accuracy, proper accuracy. That is the scenario of a bias. That is the bias. Which of the model are showing are lead high bias? That is the linear regression and logistic regression. In these two models we can find out mostly high bias. That means the model will not giving us the best accuracy. Okay, when our data is too complicated. Okay, in a scenario, consider whenever data is too complicated, we are not able to get accuracy, right? That is the bias. Means whenever the error occur in a trained data set high and test data set high, that means the underfit scenario, there we have high bias. We can consider it as a train error, right? We can consider it as a train error. Okay, in a way. So is it clear what is the bias? Now, so next question will come in a picture is like, what is the variance then? Can you try to answer this question? What is the variance then? You have understood what is the bias. So try to answer this question. What is the variance? I will write it down the question till then. Is variance. What is the variance then? Okay. Variance is a type of error that occur in the model when the model are too complex, right? And learns feature from the data. This kind of error can occur in the algorithm used to a trained model has high complexity, right? Even through the data and underlying patterns are are easy to discover, right? This, we can go with the simple example. See, whenever we have our model too complex, right? It will understand the pattern of inside the data, whatever pattern inside the data, what is the information that data giving us, that model is best fitting, right? It is giving us the best accuracy. But wherever we add a new information, new test data, and that model will not perform good, right? Because that model is just only biased with that data set, right? Whatever the data we have right now. Okay, so what happened, that is the overfitting scenario, right? Means for the trained data it is giving the best accuracy, but whenever we are adding a new data inside that, it is not giving that much the accuracy, right? So that is the variance. Okay, so in an easy way we can consider is as variance, it means the overfitting scenario, and bias means the underfitting scenario. High bias means low train low train accuracy and low test accuracy, right? High variance means train accuracy is high but test accuracy is not that much good, right? So did you understood what is the bias and what is the variance? See, variances generally lead a poor accuracy in a test data set, right? That will result a overfitting. Okay, so the error in the test data set, the high error in the test data set, that is the variance. The error in a trained data set, the high error in a trained data set, actually the model is not good. That is the bias. Okay, so did you understand what is the bias and what is the variance then? We are having underfitting and overfitting, right? That is related to each other. Underfitting, overfitting, and bias variance, right? Because of bias, underfitting will happen, and because of variance, overfitting will happen, right? Bias means the actually in in a in actual scenario our model is not good, right? So the train and test both the accuracy is less, right? But variance, that means when our model, when variance up to when our model is too complex, it is biased towards the data set that we are having. That means it is giving the best accuracy for this data. But if we add any new data, it is not giving that accuracy, right? That means it is increasing the test error for the test data. So variance just means high variance, that means the overfitting. Variance we can consider as a test error, bias we can consider it as a train error. Okay, if you want to remember those things, train error that means bias, test error that means the variance in an easy way, right? Is it clear now what is the bias and the variance? Okay. Now next question is, what is the entropy in a decision tree? I will write down the question. What is entropy in decision tree? Okay. What is the entropy in a decision tree? Okay. Now, in a decision tree algorithm, entropy is measured just only the impurity of the data, right? Or the randomness of the data. Means entropy is just telling us that data set is how much it is pure or how much it is impure, right? In a simple term, it is telling us about the variance in the data, right? We want as minimum as possible the entropy value, right? Entropy is less, that means it is the good column. It is the pure. It is the pure data set. If entropy is high, that means it is the impure data set. Okay, the range of entropy from 0 to 1. For example, suppose we have a box with a blue marble, right? Then entropy of that box is 0, right? As it contains marbles of the same color, that means there is no impurity, right? So that data is pure, right? Because there we have entropy as a 0. We want always entropy as less as possible, right? If we need to draw marble, see, if we need to draw marble from that box, right? The probability of being blue will be like 1, right? Firstly, whenever we have that box, there we have 10 blue marble, right? If we need to draw marble from that box, the probability it being blue, for that blue, probability is being 1, right? That means the data set is totally impure, right? The purity is not there. Okay. So, did you understood entropy? It just means it is measuring the impurity of our data, right? The range of entropy is from 0 to 1. We want the entropy values as less as possible, right? Okay, is it clear now what is the entropy and all? Okay, so next question is then what is the information gain? What is the information gain? In a decision tree. Okay, sorry. Okay, what is the information gain in a decision tree? Okay, so as we know, decision tree is working on the nodes. Here we have nodes, right? Every time we have to split that nodes to grow up our tree, right? For that reason, we want the node, whichever the node is giving us the high information, that we will choose for further classification, right? So when we are building a decision tree, at each step we have to create a nodes that decide which feature we should use for the split, right? That is, which feature would best to separate our data so that we can make the predictions, right? The decision tree is using information gain for that, right? Which is measure how much the entropy is reduced when the particular feature is used to split the data. Okay. See, when we want to split our data, we want to split the nodes. Sorry, we want to grow the tree. So which of the node we have to consider to grow up our tree, right? So for that reason, we are using the information gain. Okay. Information gain is just telling us or measuring how much the entropy is reduced when the particular feature is used to split, right? That means the information gain is just the summation of the entropy, whatever we have. Okay. Information gain is telling us which is the best feature to split, which is giving us the highest information. Okay. The information gain values we want as high as possible, right? Did you understood then what is the information gain in decision tree? Information gain is nothing but it is used to find out which is the feature we have to choose for further distribution, for further split, right? And it is just only the summation of the entropy. The information gain value we want always as high as possible, which of the variable, which of the node it is giving us the highest information gain, we will choose that to split further. Okay. Is it clear? What is the information gain then? Okay. So we can go with the another question. Today's next question is like, what is, yesterday we see what is cross validation. Then the next question is, what is k-fold cross validation? This is the technique for cross validation, as we know, right? Okay. What is k-fold cross validation? Okay. In a k-fold cross validation, we divide the data set into k equal parts. Okay. Firstly, we divide our data into k equal parts. After this, we loop over the entire data set k times. Okay. In each iteration of loop, one of the k part is used for testing, right? And the other means the k minus 1 part are used for the training. This is how the k-fold is using k-fold validation. Each one of the k part of the data set end up being using for the training and testing purpose. See, means whenever we are having a data set, okay, in k-fold we will divide the data into number of k's. Okay, then we can take the loop. And for that loop, every time we are taking that k times that loop is running. Okay, and it is just checking every time it is taking the new data set. right? And other that k minus 1 as a trained data set and running our model on that. That is the k-fold cross validation. Is it clear what is the k-fold cross validation then? K-fold cross validation just means when, for example, we have 100 of the variable, right? Okay, so we have divided that data into 5 number of scale, right? That means the 5 set of data we have made. The 5 set data we have maken from those 100. So in each we have 20, 20, 20 observation, right? So we will apply a loop there. Okay, it will run 5 times. Every time it will take a new data set as a test data and other 4 as a trained data, right? Next time, for the next time, it will take again the new test data and other 4 as a trained data, right? In this manner, k-fold cross validation is working. This is the k-fold cross validation technique. Understood then? Okay. So now we go today's next question. What is the F1 score and how it calculated? What is F1 score? Sorry. And how to calculate it. Okay, try to answer this question. What is the F1 score? Just only tell what is the F1 score. That also enough. Okay. So F1 score is just helping us to calculate harmonic mean of the precision and recall, right? We are having the precision and recall. The F1 score is just helping us to calculate mean of those that gives us the test accuracy, right? There are some certain condition. If F1 is equals to 1, then the precision and the precision and recall are accurate, right? If F1 score is less than 1 or equal to 0, then the precision or recall is less accurate, right? That means they are not giving us the proper accuracy. They are completely incorrect, right? So the formula for F1 score, how to calculate it, it is just only precision into recall divided by precision plus recall multiplied by 2, right? Whole formula multiplied by 2. This is the formula. Okay, so we will go with again. F1 score is just helping us to calculate harmonic mean of the precision and recall. Okay, it is giving us the test accuracy, right? If the F1 score is equals to 1, that means the precision and recall are accurate, right? But if F1 score is less than 1 or equal to 0, then the precision and recall is less accurate, or we can consider it as completely inaccurate, right? Formula for F1 score is precision into recall divided by precision plus recall into 2. Is it clear? What is the F1 score then? We will use to calculate accuracy, right? It is just calculating getting the mean of our precision and recall, right? Precision and recall, that means it is telling us the ratio of actually true positive we have. It is telling us the ratio of true positive. How many we have classified as true positive out of all the positive, right? So it is just telling us the mean of that. It is telling us the accuracy of test, right? If F1 score is less than 1, that means the mean and the precision and recall is not accurate, right? If F1 score is 1, yeah, that means it is good. It is accurate. The precision and recall is accurate. Okay, is it clear for you? What is the F1 score then? Okay. Okay, then thank you so much, friends, for your time. Okay, that's it for today. Thank you.